Hello, this is Mr. Humbard again. For this video, I'm going to be going through this Chapter 3, Section 2 assignment for the all three of them. So this should be Part A. There's B and a C as well. So this first problem is from rest. It's another from and to problem. So it's going to be 22 minus 0 over 2.3. We're just using this equation every single time. And then solve for the acceleration equation every single time. This whole assignment's just using this set. So whatever that value is, 2 divided by 2.3. Oops. Looks like it's 9.565 something, and then it's 1 decimal, so I just round that to that decimal. 9.6. Right. So if we want to do this problem, there's our time, 7.8 seconds. S stands for seconds. She starts from rest, so V initial is 0. And then we have our speed. So that's our V final. So our acceleration is just change in velocity over time. So we have to do V final minus V initial. So 18.8 minus 0, which is our initial, over 7.8. 18.8 divided by 7.8 should be 2.410, and it's 2 decimals, so we ignore that thing. So 2.41. All right. So for this number 3 problem, our initial velocity is positive. It's going toward the wall. And using our equation, A equals V final minus V initial, I'm going to plug all these values in. So initially, it's thrown towards the wall. We'll assume that's the forward direction is positive. So 13.7. And then it returns with a velocity of 11.2. Because velocity is a vector, the sign matters. So there's going to be a negative 11.2 here over the value of time is going to be 0.023, because that's an S, stands for seconds again. These are in meters over seconds. All right. Once we do that, we should get 11.2, 13.7, add those divided by 0.023, and I get, I'll put it over here actually, 1082.60, but that's to no decimals, so it's just, and it's a negative value because the negative's up here. So negative 1083. And that's in meters over second squared, because meters over second is meters over second squared. Right? So our next problem, number 4, is about a drag racer. Here is his acceleration, A. He starts from rest, so V initial equals 0. And there's our final speed. The key here is this is in meters over second squared, and this is in kilometers per hour, km over h. So we have to convert that to meters over seconds. So 389 kilometers per hour. First, I'll convert to meters. So 1,000 meters is in 1 kilometer. And then I'll convert to seconds. So 1 hour is 60 minutes. And then 1 minute is 60 seconds. Well, cut enough page there, but it's okay, I'll just go this way. So that's going to give some value, 389 times 1,000 divided by 60 times 60 is 3,600. $108.055556. And the reason I'm keeping so many decimals is I don't want to make a mistake here, because sometimes if I don't and I round off early, I might make a little mistake and it could be off. So once I have that value, I have to use my equation for A equals V final minus V initial over time. And I have to solve it for time, so time over A, both sides. So once I do that, I should get whatever's on top divided by 16.7. I do that and I get 6.470, and then it's 3, but it's 2 decimals, so we leave it like this. Here's our answer. And this is in seconds. So last problem. Here's this initial speeds. She roller skates at a speed along the top of the hill. She then, so after, she skates downhill with an average acceleration of 0.88. This is her final speed, 10.3. So it even says final speed. So then we just do the time again. So time equals change in velocity over the acceleration, like before, like we have up here. So when we do that, we're going to get final minus initial over acceleration. And this is going to give 10.3 minus 4.8 divided by 8.88. That's 6.25. And there's a 5 there. We round that to 1 decimal, so it's 6.3. That'll be our answer. All right, that's it.